Hey guys, on to lesson 6.2, the only one in 6.2, solving systems by using this thing called substitution. Our objective is to solve a system using substitution, substituting something in for something of equal value. So with graphing, sometimes the equations will not always line up nicely where they intersect. So there's this other method called substitution. The goal of substitution is we want to pretty much, excuse me, turn both of those equations into one equation that has one variable instead of two equations with two variables. And it really is quite simple. Okay, here's a brief example, and then we'll get into some notes about it. Okay, so here's a very basic system: y equals 2x plus 2, and x equals -3. Notice x equals -3. It's kind of telling you part of it already. Since x equals -3 and the x value in each equation are equal, what I can do is just plug this x value right here into the x value up here. And that's exactly what I have done. All right, so y equals 2x, but instead of x, here we have this -3 plus 2. I then simplify y equals -6 plus 2, and y equals -4. And that's the system. That's the solution, I should say. I'm sorry. The solution would be -3, since that's what the x is given to us, and the y is -4. That's the solution. Now, that's very basic. This is going to be the process to do it. You may need to pause this next page because it's a couple steps, okay? And I don't want to waste my time just reading it to you. But here's how you solve a system using substitution. You need to isolate. Step one, you need to isolate one of the variables in one of the equations. It doesn't matter if it's x or y. It doesn't matter if it's the top equation or bottom equation. Sometimes that'll be done for you already. Step two, you're going to substitute what that equals, the equivalent value, into the other equation's variable. Sounds complicated, but it will make sense as we do examples, I promise. Then you're going to solve that new equation using methods we've already learned, like solving an equation, and then you'll get one of your variables answers. After that, step 4, you plug that into one of the original equations and solve the other variable. And step 5, you're going to write that as an ordered pair and check. All right, again, you may want to pause, jot these down. I'm going to move on to the example now. So here's my first example. All right, solve this system using substitution. Notice it's not really set up great for graphing. It kind of is, but what we want to do first is we have to choose a variable that is easy to solve for, meaning I have x's and y's to choose from. Usually we solve for y. It doesn't always have to be y, but if I look, this y has a 2 in front of it. It's going to be a couple steps. This y has a minus sign in front of it. That's not going to be easy. Notice both of these x's, they're by themselves. All right, I'm going to pick this top x, and I'm going to isolate that x in the top equation. All right, so here I'm starting it down here. Here's that equation. There's the x I want to isolate. Okay. My house just shook. I'm not sure what that was about. What I'm now going to do is subtract away 2y from both sides. And when I do that, I'll have x by itself. So x equals -2y minus 1. So this is the same exact equation as the top one from the system. We just transformed it a little bit. And now notice, x equals this, meaning x and -2y minus 1 are equal to each other. All right, since now we have isolated one of our variables, we can substitute what x is equal to, which is -2y minus 1, into the other x of that other equation, my bottom equation. All right, so here I have it written a little bit differently. So here's my first equation, which we've rearranged. Notice it's the same right here. And what I'm going to do is I'm going to plug this, which x is equal to, into this spot right here, because that's what x is also equal to. And it's going to look like this now. All right, what I'm putting in parentheses is this. All right, notice after that is minus y equals 5, minus y equals 5 right here. Those are the same. The only difference is I substituted what x was equal to into that x value. All right, and now look at this equation. It's only y values. Now we can solve this equation for y. So now take a look. What do I do to solve this for y? Oh, I have like terms. I can combine my two y values. Negative 2y, negative y gives me negative 3y. Now what am I going to do? I'm going to add 1 to both sides. Gives me negative 3y equals 6. What am I going to do? I'm going to now divide by negative 3. I'll show you right here. Divide by negative 3, divide by negative 3. So y equals negative 2. So my y value of my solution, if I want to think about it, I know my y value is negative 2. I'm halfway there. Actually, we're more than halfway there. Okay, I know that seemed like a lot. Since we know y equals negative 2, now what I can do is plug that into one of the original equations in for y, and then solve for x. So I'll show you what I mean. I go back to my original. Since I know y equals negative 2, I can plug it in there, or I can plug negative 2 in there, and then solve for x. So scrolling back down, that's exactly what I have done here. I took that second equation right here, and I'm just replacing the y with negative 2, okay, because I know that's my solution. And now, since this is pretty much x plus 2, I would need to subtract 2 from both sides, and I get x to be 3. So my final solution here is just going to be 3, negative 2. I know that was wordy and lengthy. It does get quicker, but the first time explaining it, there's where it is. All right. Now, sometimes we may need to use the distributive property when solving by substitution. What that means is something like this. All right. So here I have a system I want to solve by substitution. First step, I want to isolate one of my variables. Look at the top equation. Both of those x's have an x has a 2, the y has the 2. Oh, look, this is isolated. All right, so what that means is I'm going to say y equals x plus 3, meaning y and x plus 3 are the same thing. So anywhere there's a y, which I see here, I can plug in x plus 3. So that's exactly what I'm going to do right here. I'm rewriting the top equation, 2x plus 2y, but instead of y, I plugged in x plus 3, and that equals 38. And now what I'm going to do is I'm going to distribute to simplify 2x plus 6 equals 38. I'm then going to combine my like terms. I'm going to subtract 6. I'm going to divide by 4, and I get my answer for x. I'm not done because my solution is an ordered pair, but my x is equal to 8. And now what I'm going to do is I'm going to plug in. Oh, no, it didn't work. It went away. Now what I'm doing is I'm going to plug in 8 into either equation. And what I'm telling you is look at this bottom equation. If I plug 8 in for there, that x, to find y, it's quite simple. Y equals 8 plus 3. So my x was 8. My y is going to be 8 plus 3, 11. And this is the solution. Let's do it. I have 2 more examples. I'll go kind of quickly so you can pause, rewind, whatever you need to do. Here I have a system. The top one already says x equals. So what I'm going to do is I'm going to plug that in for that x. So this equation I'm going to show you right now, take a look. This says 7x because x is equal to negative 2y plus 4 plus 14y equals 28. I'm going to distribute. Oh, it's not working. I'm going to distribute, and I'm going to get 14y, negative 14y plus 28 plus 14y. That equals 28. And now I'm going to look. I want to combine my like terms. Negative 14y and positive 14y, they cancel each other out, and I'm left with 28 equals 28. That's a true statement. So 28 does equal 28. Variables canceled out. We're left with an identity, which means this has infinite solutions. All right. So if you end with an identity with a system, it means you have infinite solutions. Last example. Oh no, there's the solution. Oh man, delete that. Okay. So we have y equals 3x plus 11. Oh, one of my variables is already isolated. Nice. Y minus 3x equals negative 13. I'm going to plug in this value for y. This value, 3x plus 11 is y, minus 3x equals negative 13. Notice positive 3x, negative 3x, they cancel each other out. So I'm left with, there's that 11 equals negative 13 thing I showed you before. Wait a second. Say, what? Negative 13. I'm sorry, 11 doesn't equal negative 13. That's a false statement. If you end with a false statement, variables are gone, and you're left with a statement that's not true, that means this has no solutions. All right? This has no solutions. And that is everything. Practice is U8 for IXL, solving systems by substitution in Khan Academy, and that is it once you're done your mastery check.